For today's lesson, we're going to move on to section 10.2, which is about finding arc measures. To start off with, we need to talk about a central angle. A central angle is an angle whose vertex is at the center of the circle. So in this circle, we could draw a central angle here. Angle ACB is a central angle of circle C. Remember, the circle is named by the center point. When you have a central angle, it splits the circle into two arcs. An arc is a part of a circle. If the measure of angle ACB is less than 180, then the points in the interior of angle ACB form a minor arc. So in this diagram, this is a minor arc. A major arc is the points that do not lie on the minor arc AB. So the rest of this circle, all the way around, is a major arc. A semicircle is an arc with endpoints that are the endpoints of a diameter. So when you have a diameter, A and B and circle C, we have a semicircle on one side and a semicircle on the other side. Just like angles and segments, we need to know how to write the names of these arcs. With a minor arc, you can name it just by its endpoints. So if we draw in, for example, the central angle AOB, this arc here would be named arc AB. So I use the two endpoints, and then the symbol for an arc is an arc over the top of the two letters. In this picture, I also have another minor arc over here, arc DC. I also have another minor arc going this way from A to D, or over here from B to C. I know that I would go the shortest path from A to B because I've only named it with the two endpoints, so it has to be a minor arc. For a major arc or semicircle, you have to name them by the endpoints and a point on the arc. So, for example, if I wanted to go from A all the way around to D, I could name that arc A, B, D. ABD is the same arc as ACD. I start at A, I go through B, I end at D. I start at A, I go through C, and I end at D. Those are two different names for the same major arc. For a semicircle, I, for example, could use ADC. That's the semicircle that starts at this end of the diameter, goes through D to C. If I wanted to go in the opposite direction, I would have to name it arc ABC. The measure of an arc, the measure of a minor arc, is equal to the measure of its central angle. So if I look at this circle up here, and for example, if this angle was 40 degrees, we would say that the measure of this arc is also 40 degrees. When you write the measure of an arc, you do it the same way you do with angles, a lowercase m, and then the name of the arc equals the value. If the minor arc has a measure equal to the central angle, the major arc is the rest of the circle. So it's going to be 360 degrees minus the measure of the related minor arc. So minor arc AB is 40. So major arc ADB would be 360 minus 40, which is 320. Every semicircle has a measure of 180 degrees because it is half of the circle. With arcs, we have adjacent arcs, just like we have adjacent angles. Adjacent arcs are two arcs of the same circle that have a common endpoint. So if I look at this diagram down here, I have an arc AB and one arc that it is adjacent to. If I started at B and had this same shared endpoint, I could say it's adjacent to arc BC. Arc AB would also be adjacent to arc ADC or arc BCD, or sorry, that would just be BD because it's a minor arc. So we just need to have one common endpoint. Arc addition postulate says the measure of an arc formed by two adjacent arcs is the sum of their measures. So if we look in the diagram down here, it says the measure of arc AB plus the measure of arc BC equals the measure of the whole arc. We can see this and prove it by thinking about what we know about angle addition postulate already. So if I connect A to O, B to O, and C to O, we would use angle addition to postulate to say the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. This angle plus this angle equals the whole angle. Well, what we said before is that because these are minor arcs, arc AB and arc BC, they are equal to the measure of their central angle. So the measure of angle AOB is the same as the measure of arc AB. And the measure of angle BOC is the same as the measure of arc BC. The measure of angle AOC is equal to the measure of arc AC. Since these central angles are equal to the measure of the minor arcs, we can prove arc addition postulate easily. We're going to do a bunch of problems where you're given some angle measures or some arc measures and have to find everything else. In this problem, we know MQ and NR are diameters. And we're given the 81 degrees and the 73 degrees. This angle is 73, so we know our vertical angle is 73. We have the 81 here, so if we wanted to find the measure of arc of this angle in here, I would do, since NR is a diameter, I would do 180 minus 81 minus 73, and that would tell me this angle is 26. And then if I wanted to find the measure of angle MOR, I have a diameter, so 180 minus the 73 is 107. And now that you know these central angles, you can find the measures of all the arcs. Arc MN is a minor arc, so it's equal to the measure of its central angle. Arc NQ, N to Q, is going to be equal to the measure of its central angle, which is 81 plus 26. This is going to be, oops, over here, 107. This is a major arc, NQR. NQR, it's actually a semicircle because the N and R are the endpoints of a diameter, so this is 180. And these are all in degrees. MRP, M to R to P, goes all the way around, so we can either add these three angles together, or we can do 180 minus those two. I have 107 plus 73 plus 26, which is 206. And again, degrees. Arc PN, P to N is the same as its measure of the central angle, so that would be 81, and so on. You would work your way through all of these, adding together the pieces of the central angles or adding together the arcs to find your measures. Remember, every major arc should be 180 or greater. Every minor arc has to be less than 180. Here, we're going to try to find the measure of arc DH, but we're given everything in terms of variables except for this 190-degree angle. And if we look, DG is a diameter, which means that arc DEG is a semicircle. So that semicircle has to have a measure of 180 degrees. The semicircle has minor arcs. We can look at the central angles or we can look at the arcs. We have to add 2x plus 90 plus x. So I'm going to subtract the 90. 2x plus x is 3x. So x must equal 30. So then if I want to find these two arcs, I want to find the measure of DH. I need to know what 2y is, or I need to find out what this angle is here. Arc DH is going to be the same as arc EG because we have vertical angles here. So this is 90 plus x. 90 plus 30 is 120. The measure of arc DH is also 120. I don't need to find y in order to find that arc. In order for two arcs to be congruent, two things have to be true. They have to have the same measure, remember that's the number of degrees, and they must be in the same circle or congruent circles. If we look at these diagrams here, this could be a 30-degree arc in this circle and a 30-degree arc in that circle, but because the radius of this circle is so much bigger, these are not congruent arcs. Congruent figures have to have the same size and shape. We should be able to pick this arc up and make it exactly fall on top of this one. That won't happen if the radius is different. So same circle or congruent circles, which means they have the same radius. So if we look at these diagrams, we want to check, is arc AB equal to arc CD? They have the same measure, so that part's good. The question is, are they in the same circle or congruent circles? In this case, this length is the radius of both circles. So they are in congruent circles and they have equal measures. Yes, they are congruent. Over here, we can see that the radius of one circle is shorter than the radius of the other circle, so they are not congruent arcs. Down here, we want to check about AB and CD. We need to know the measure of this central angle. So we're going to take 180 minus 63 minus 54, which is 63. So now we have, oops, this is 63 degrees, this is 63 degrees. They have equal measures, and they're in the same circle. So yes, they are congruent. And that is it for today.